So today we will continue with the addition subtraction of rational expression, but specifically when we have different denominator. Remember, rational expressions are fractions, are algebraic fractions. So in order to sum subtract fractions with different denominator, remember we must find the least common denominator, or also called least common multiple, between the denominators in order to transform or convert our two or more algebraic fractions into fractions that have the same denominator, and then it will become an exercise from the last topic, because when we convert it to the same denominator, it will be an exercise like addition subtraction with the same denominator. Remember, after that, when we have the same denominator, we must simplify the final rational expression, and of course, we need to order alphabetically our letters. So let's see the first example. On this one, the first thing we need to do is we need to obtain the least common denominator or least common multiple. So first, between 10 and 4, we can do the prime decomposition. And it's going to be 20. So it's going to be 20. What about the letters? Remember, we need to put all the letters we have. So it's going to be A, B, and C. And we need to put the highest powers of those letters. So it's going to be A to the 4, B is going to be to the third, and C is going to be squared. That means we will transform our fractions to have the same denominator, that it's going to be 20 A to the 4 B cubed C squared. So then we need to compare this first one with this denominator. So it's going to be, in this case, I will need that the 4, it's going to be multiplied by 10 to become 20, it's 2. What about the letters? A squared to become A to the 4, we need A squared. B to become B cubed, we need B squared. And we don't have C, so we need to have C squared in order to become C squared. What happens next? It's going to be minus, and we will have 12 A squared M to the third B minus 2 C squared A squared B squared. And let's compare that specific denominator. If we compare 4 and 20, of course, we need to multiply it by 5 in order to become 20. Let's see about the letters. We have A to the 4. To become A to the 4, we don't need anything. B cubed to become B cubed, we don't need anything. C squared to become C squared, we don't need anything. So that's why the second part, we only multiply it by 5. So what can we do next? It's going to be 4 times 2. It's going to be 8 A squared B squared C squared minus, we can multiply the 5, and it's going to be 60 A squared M cubed B minus 10. We can put it in order. A squared B squared C squared, all of it divided by 20 A to the 4 B cubed C squared. After that, we can take out the parentheses. Remember, a minus sign before a parenthesis means both terms will change sign. So it's going to be minus 60 A squared M cubed B plus 10 A squared B squared C squared, all of it divided by 20 A to the 4 B cubed C squared. After this, we can look for those terms that are common to make like term simplification. These 8 and these 10 have the same letters and the same powers, so they can be added. And it's going to be 18 A squared B squared C squared minus 60 A squared M cubed B, all of it divided by 20 A to the 4 B cubed C squared. after that, we need to simplify our final rational expression. How to do it? On the top part, we have a polynomial, so we need to take out a common factor in order to have factors that can be simplified. So 18 and 60, both of them are divisible by 2. What about the common letters? We have a squared on both. We have b on both also, so it's going to be 2 squared, 2a squared b. So 2a squared b to become 18, it's multiplied by 9. A squared to become a squared, we don't need anything. B to become b squared, we need a b. And we need c squared. Minus, and it's going to be 2 to become 60, it's 30. And it's going to be a squared to become a squared, we don't need anything. Then it's going to be b to become b, we don't need anything. And finally, we need m cubed. All of it will be divided by 20, a to the 4, b cubed, c squared. So after that, we can simplify it because it's going to be 2 and 20. It's going to be only 10 on the bottom because we can simplify it. What about a? We have a to the 4 on the bottom, a squared on the top, so we can eliminate it, and it's going to be a squared on the bottom. What about b? It's going to be b squared on the bottom. What about c? We don't have anything, so it's going to stay the same, and it's going to be 9bc squared minus 30 m cubed. Of course, maybe we can take out a 3 as a common factor on the top part, but it won't eliminate with the bottom part, so it's the same. That's why I only take out a 2, not a 6 as a common factor, because 18 and 60 have 6 as a common factor. But this is going to be our final answer. So how to do this kind of exercises? It's like that. We need to have the same denominator in order to make a normal addition subtraction of a rational expression with a common denominator. So let's see another example. So let's see, in this exercise we have polynomials as denominators. So remember, in order to find the least common multiple, or in this case the least common denominator between polynomials, we need to factorize them. So let's factorize them, and it's going to be 1. Here we can take out 9 as the greatest common factor, and it's going to be 5x plus 1. Here we can take out a 3 as a common factor, and it's going to be 3x minus 2. Minus, and here we have an ax squared plus bx plus c trinomial, so let's factorize it here, and it's going to be 15x squared minus 7x minus 2. So the multiplication of the corner is going to be minus 30x squared. So it's going to be 15x squared minus to become a minus, we need a plus. So two numbers that when they get added it's 7, when multiplied it's 30, are going to be minus 10 and 3. So from the first two, we can take out a 5x, and it's going to be 3x minus 2. And on the second one, we can take out a plus 1, and it's going to be 3x minus 2. So it's going to be 3x minus 2 that multiplies 5x plus 1. That means this one is going to be 2x plus 1 over 9. All of it divided by 3x minus 2 that multiplies 5x plus 1. So here, to obtain the least common denominator, remember it's going to be between the numbers I got 9 and 3. If I do the prime decomposition of those, it's going to be 9. And with about the parentheses, remember we need to put all the parentheses we got and the highest power we got. So the least common denominator will be, 3x minus 2. I don't know why I put it plus 1. Minus 2. So that will be the least common denominator. So we can change our fraction in order to have the same denominator, that it's going to be 9, 5x plus 1 that multiplies 3x minus 2. So now we can compare this denominator with this denominator. The only thing that we are missing is the 3x minus 2. That means it's going to be 1 that multiplies 3x minus 2. On the second one, the 5x, we are missing a 3 because we need a 9 and we only have a 3. And we are missing the 5x plus 1. The 5x plus 1. And on the last one, we are only missing a 9 because we got both parentheses. So let's check out on this one. Of course, these two, it's 15x, the multiplication of these two. So it's going to be 3x minus 2 plus 15 times 5. It's going to be 75x squared plus 15x minus 9 times 2, it's 18x minus 9 times 1 over 9. 9 and 9 will simplify. That's going to be minus 1. All of it divided by 9 that multiplies 5x plus 1 that multiplies 3x minus 2. So here we can make the like term simplification on the top part and on the bottom. So it's going to be 3x and 15x. It's positive 18x. With the minus 18x, it will disappear. So we will get only 75x squared minus 3. All of it divided by 9 that multiplies 5x plus 1 that multiplies 3x minus 2. So here we can start taking out a 3 and it's going to be 25x squared minus 1. All of it divided by 9, 5x plus 1 that multiplies 3x minus 2. So we can continue doing it because here we have another thing that can be factorized because it's a difference of a squares. So it's going to be 3 that multiplies 5x plus 1 that multiplies 5x minus 1. Remember, it's the square root of the one that do not change, of the positive one that doesn't change sign, and the square root of the negative that it will be positive on the first parenthesis, negative on the second one. So now we have only factors. We can simplify them. And it's going to be this 5x plus 1 with this 5x plus 1. This 9 is like having 3 times 3. So this 9, it's like having 3 squared or 3 times 3. So this 3 with this 3 squared. So our final answer can be 5x minus 1. All of it divided by 3 that multiplies 3x minus 2. We can left it like this, our answer, or we can put it also like 5x minus 1 divided by 9x minus 6. It's the same answer. So remember, in these cases, of course, it's a little long process, but the idea is the same in every exercise. We find the least common denominator. Why? Because we need to transform our fractions to have the same denominator, and in that form we can do our simplification of our rational expression. Remember, the answer must be always ordered and the most simplified we can. So let's see one last exercise. So let's see, in this exercise we have again polynomials as denominators, so we need to factorize them in order to check out the least common denominator. So let's see. Here, a little recommendation. We have a minus x squared. This one will be an x squared plus bx plus c trinomial. So maybe we can take out this minus sign here, and this one will be positive, and it will be easier to factorize. So let's see. X minus 3 divided by x squared minus 1 minus 5x minus 4. And of course, every term on the denominator will change sign. X squared minus 3x plus 2 minus 4 divided by 2 minus x. So let's factorize every denominator. So it's going to be x minus 3. This one, it's a difference of squares. So it's going to be x plus 1 that multiplies x minus 1. What happens next? It's going to be x minus, two numbers that when multiplied, it's going to be plus 2. When added, it's going to be minus 3, minus 2, and 1. So let's check here also. We can do the same trick again. Why? We have here x minus 2. And we have here 2 minus x. If we take out the negative sign, it will become an x minus 2. And it will be the same this one and this one. So if we change the sign here, and we change the signs on the bottom, we will have x minus 2. What will happen then? Our least common denominator will be composed of all the parentheses we got with the highest power. That means x plus 1, x minus 1, and x minus 2. So now we can have the same denominator here, and that denominator will be x plus 1 that multiplies x minus 1 that multiplies x minus 2. What happens next? Remember, we need to compare this denominator with this denominator and see what is missing. So it's going to be x minus 3 that multiplies the one that it's missing, that it's x minus 2. Then it's going to be minus 5x minus 4. The one that is missing here is going to be x plus 1. And finally, it's going to be plus 4. Here we have 2 that are missing, that it's going to be x plus 1 and x minus 1. So we need to make our multiplications. If we remember special products, it's going to be easier. If not, we can make the whole multiplication on all of them. Don't worry about it. So on the first parenthesis, it's going to be x squared. Then it's going to be minus 5x plus 6. Then it's going to be minus. Here we can multiply every term, and it's going to be 5x squared plus 5x minus 4x minus 4. And actually here it's going to be 4 that multiplies. We have a product of the sum and difference of a binomial, x squared minus 1. All of it that it's divided by x plus 1, x minus 1, and x minus 2. So let's see. It's going to be x squared minus 5x plus 6 minus 5x squared. 5x and minus 4x is only 1x, minus x, minus multiplied by minus, it's plus 4, plus 4x squared minus 4. All of it divided by x plus 1, x minus 1, and x minus 2. We can do now the like term simplification, and let's see. X squared, 4x squared minus 5x squared will disappear because 4 and 1 is 5, minus 5 it's 0. So it's going to be minus 6x. 4 and minus 4 will disappear, so it's going to be minus 6x plus 6. All of it divided by x plus 1, x minus 1, x minus 2. After that, we can take out as a common factor, we can take out the minus 6. Is going to be x minus 1. All of it divided by x plus 1, x minus 1, and x minus 2. So we can eliminate this factor with this factor, And our final answer is going to be minus 6, all of it divided by x plus 1 that multiplies x minus 2. And this one is going to be our final answer. Of course, maybe we can also multiply the ones on the bottom, and we can say like this answer can be also, I'm sorry, minus 6 divided by x squared minus x minus 2. And that's the same answer. Remember, we can left our answer like in factors, or we can multiply the factors. Both answers are correct. So that will be it for today's topic. That was addition, subtraction of rational expressions with different denominators. Let's see each other on the next video.